Right, so in the beginning I'm going to give some arguments for why one might use lightweight markup when preparing a document. Then I will outline some of the existing solutions, and then I will give an overview of the package I authored and offer some conclusions and discussion about what I've achieved, what should be changed in the future, and so on. So TeX as a content creation language has a couple of problems, in my opinion. One of the problems is the high markup to text ratio. So when you look at the text book, so I try to compute how much there is markup compared to the actual content, to the actual text, and it is about 20%, and the same thing is with a book I somehow picked at random, which has a source in LaTeX openly available. It is also about 20%, which is
the number of characters.
Yeah, it's in the number of characters. Yeah, I'm comparing the number of characters of the text and the number of characters in the, I guess, yeah, something like slash indeed. Yeah. The other thing is that you have virtually no sandboxing. I mean, if you create a document such as this, then the document will probably not compile. Also, as was already mentioned, TeX is Turing complete, so you might create constructions which will just hold the typesetting process for an infinite time, so that you have to set up some timeouts if you want to automate the typesetting of some content authored by someone who is not too familiar with TeX, or someone who has a malicious intent to break your program. And also, if you typeset with enable shell escape, then you basically have to sandbox the entire thing. Otherwise, the author may delete your whole list. And there's also the steep learning curve, right? I mean, you can give someone LaTeX and tell him go create a document. It takes some time to learn the intricacies of the syntax of LaTeX. So, if a beginner sees this, they are not going to be very happy, in my opinion. I tried this on some members of my family. They weren't very happy with that. And if instead of LaTeX you use Markdown, the same structure, the same content, you get something like this, which I think is much more readable and intuitive to a user who hasn't heard of that. Right. So the advantages of markup as a content creation language is the minimal markup to text ratio. I mean, some of the O'Reilly books are written in Markdown and then I suppose converted to XML book and then either converted to PDF and HTML, but their sources are available in GitHub. And the decrease in the amount of markup is really enormous. It's like basically the entire source files are just the content. There's very little in the way of markup. And then you can either choose to have sandboxing, so you allow no plain text specials in the input, and then you get complete sandboxing for free. Or you may support hybrid markup when you're writing the documents yourself, and you just can combine Markdown and TeX. You can just use Markdown if you're marking up some really simple sections for most of your text. It probably will be, if it's not too complicated, then you can use just Markdown. And when you need to do something more involved, then you can just use a couple of tag macros and then just fall back on Markdown. So you get the benefits of both. And the benefit is the mild learning curve. I don't have any studies confirming this, just this. Yeah. Right, so one of the existing solutions is Pandoc, which is a project by McFarlane. It's a Haskell package which basically is FFmpeg for documents. You take some document in a format and you convert it to another document in another format. It's mostly meant for multi-target publishing. The magic is that it has its intermediary format, an abstract syntax tree format. So each markup language, such as Markdown, LaTeX, or HTML, XML notebook, has a converter which converts from the abstract syntax tree and to the abstract syntax tree, and this intermediary format is used to make it easy to convert from anything to anything. And you know, it's a multi-target publishing software, but it's really useful when you just need to do something by hand. When you have some HTML file and you need to get it quickly to LaTeX, then you just use Pandoc, and sure, something will be lost along the way, but you know, you can change it by hand. It's a really useful tool for day-to-day document editing.
If it's real HTML, nothing is supposed to be lost. In the conversion from HTML to LaTeX.
Yeah. Nothing should be lost, but I'm not sure the abstract syntax tree supports all the features of all formats. So if you convert to the abstract syntax tree and then you convert back to LaTeX, it's not the same source, and sometimes some parts of the markup are lost along the way.
Isn't the internal format of Pandoc based on Markdown itself?
No. Well, the abstract syntax tree of Pandoc is a bit limited. It has things like paragraph, and then it has something like a span. But things like attributes of different elements, etc., they are definitely lost. So
yeah.
So
how about text flash left or flash right? That's why I know Pandoc does not support that.
I'm not sure.
But notably, there is full support for math. So the abstract syntax tree format, it is able to carry math across the different formats. Right. So there is a couple of problems with Pandoc. The first thing which is kind of difficult is changing the output markup. So what you get when you convert this LaTeX document to this Markdown document, to LaTeX document is this. And I mean, you could basically redefine the macros, the standard LaTeX macros, but I mean, this is not something you want to do, especially because the output format is not fixed. I mean, you could certainly create a output module which would take the abstract syntax tree produced by Pandoc and convert it to something you need, but you know, that's a hassle. And if you just take the LaTeX output produced by Markdown, produced by Pandoc, then you end up with this, and it's difficult to change how the individual parts are rendered. The output is mostly presentational markup rather than logical in many cases. The other problem is that it's not a part of text distributions. So if you want to create a document in Markdown and you're working on Overleaf, a service such as Overleaf or Shell LaTeX, then you have no easy way to use Markdown because tools like Pandoc operate on top of tag rather than in tag. It's a tool which treats LaTeX or tag as a black box. So it's not at all easy it's basically impossible to use at services such as this. And the other problem is that you, at least I don't know of any way to like force the tool to be either hybrid or sandbox. It tries to be smart. So when it detects that there is math, it preserves the math. This is a LaTeX document, and this is the corresponding. This is a Markdown document, and this is the corresponding LaTeX document. So when it detects math, it tries to like keep it there. It will escape some things like this, and some things it will not escape, and some things which you would really like it to escape, it will also not escape. So that's sort of another issue, that you can really tell it, I need these documents not to have any text input in them. Like if the user types in some backslashes and stuff, you really have to escape this. I don't think there's a way to tell that kind of. And this extends also to multi-markdown, I think. I mean, feel free to correct me, but I think multi-markdown is haunted by same design issues. Right. So these are the reasons I thought it would be nice to have some other solution to this problem, which might be the Markdown package which I offered. Right. So the first thing that I needed to do was to pass Markdown. And although there are language parsers written solely in TeX, they were mostly for regular languages or for context-free languages. But the thing with Markdown is that it's not context-free. You can have things like these, where you surround the code with any amount of backticks you like, and then you can, and if you surround it with n backticks, then you can have n-1 backticks inside, and it will not end the code path. Which is like nice, because you do not have to do the backslash escaping thing, but it makes the language harder to pass, at least from the theoretical standpoint. And also, there is no limited lookup. You can have an entire document which you think you're passing a link, but then you come to the end, you backtrack to the very beginning, and you have to try again. So, and implementing this in TeX is not at all easy, or perhaps I'm just not strong enough, but I decided it would be better to find some other way to implement the parser. Right, so instead of TeX, I used Lua. Yeah, I don't think I need to introduce Lua. The thing is that I prepared this with PDF TeX in mind. I mean, Lua TeX is nice, but I wanted for the users at my university who mostly use PDF TeX, which is much faster than Lua TeX, still. So I wanted them to be able to use this package. And the nice thing about Lua TeX is that with a bit of work you can, and with enabled shell escapes, you can spawn a shell. You can spawn a shell which executes the Lua code externally, and then you can input the produced document. So it's not very clean, but it works. So you can do this. It produces the same output. Yeah. So what I used for the parsing was a Mark library, also by McFarlane. And in the Mark library, the language of Markdown is specified using a parsing expression grammar, using the lekki library, and a bit of cheating, because some of the counting of the backticks is done using some local variables, but mostly it's hard to specify Markdown using a grammar, but a large portion of it is specified using a formal grammar. And the nice thing about LunaMark was that its dependencies were either all compiled into Lua TeX, such as the LPEG library for the parsing or SLN Unicode, and or unnecessary. There were some libraries which just added some functionality which I did not need, so I got rid of them. And the nice thing was also that the library had been released under the MIT license, which allowed me to incorporate it and sub-license it on the LaTeX project public license. Right. So the high-level overview of what the package does is it receives a Markdown source such as this, and it produces a logical abstract syntax tree encoded in TeX, or in plain text to be more precise, as the output. And then there is a plain text macro package which defines all these Markdown render ellipses, macros, and then just typesays the document. It inputs it and typesays it. Right. This is sort of a block diagram of the package. So there's the Lua code, which you can interface with directly from the user code. Then there is the plain text interface, which interacts with the Lua interface. So the user doesn't need to use Lua. They don't want to. They just use the plain text interface. And then there is basically a syntactic sugar layer, which adds syntactic sugar for contact and plain text. And not just syntactic sugar, there are some idiosyncrasies. Neither contact nor LaTeX are completely like supersets of plain text. So there's some code which deals with that, so that all works nicely. But mostly they are just syntactic sugar, and they also provide reasonable defaults, because the plain text interface can provide reasonable defaults for the renderer macros. So the LaTeX and contact package can really provide reasonable defaults, because both contact and LaTeX have reasonable macros for types of section or a list or something. So that's another role of these top level layers. So this would be a Lua code. If you wanted to use the package for Lua, you would first load the kpath C, then you would require the Markdown package, then you would just create a converter object. In the curly brackets you would pass the options for the package. Then you would feed it some text, and you would get the text source code as the output. If you use plain text, then you would pass the options to the package through Markdown option ellipsis macros. You would also then be able to redefine the renderer macros, so you would decide how you want to render the individual Markdown elements. And then you have some macros such as Markdown input, which really takes a Markdown file, processes it, and inputs it, or the Markdown begin and Markdown end macros, which basically buffer all the text in between and then process it much like the Markdown input command, with some limitations, of course. I mean, if you use Markdown begin and Markdown end, then you can't, for example, have a text Markdown end in the Markdown source. So if you need to really process an arbitrary Markdown code, then you need the Markdown input command. But for most users, this is fine, and you don't have to break your source code into multiple files. This is what the contact interface would look like. The only thing which changed is basically the use module clause, and the rest is basically just the plain text interface. Yeah, there isn't much in the way of a syntactic sugar. Also the start Markdown and stop Markdown command, so that it's somehow consistent with the syntax, or not syntax, but the naming conventions that contact uses. And then there is the LaTeX interface, which uses the environment mechanism to start the Markdown text, and you can, instead of redefining the render macros, you have a nice key value key value interface to redefine the options and the renders in a single Markdown setup command. So there's a bit more syntactic sugar because LaTeX was really like the main target, so I wanted to make it as nice as possible. Right. So in the rest of the examples, there will be some examples, and in the rest of the examples I will use the LaTeX interface for ease of exposition. But with minor adjustments, they will work in plain text, contact, and any of the other formats. Right. So this was one of the reasons why the package was created. So we have full support for hybrid and sandbox modes. So the first code produces this. All the specials are escaped, whereas this code will produce this. As you can see, everything is kept intact. I mean, in some cases, the Markdown and the tag, the Markdown and the LaTeX in this case, syntaxes may clash, but in most cases it works out quite nicely. Yeah, this is how we might map a Markdown token to a tag macro. Suppose you have a link. This is how you mark up a link in Markdown, and here you define that you want to take the first argument, which is the label of the link, and just put it there, and then you want to take the URL and the title and put this into a footnote, and this is what you get on the output. It's really easy to just say what you want, how you want to render your Markdown.
How does it relate? Link. A link is over there. This is in the Markdown. It's in the.
Yeah, this is basically the code, and I'm sorry, I keep on going to the previous slide. This is basically the code, and this is what gets produced.
Yeah. How do you relate the text? How do you relate the Markdown text to the macro? How does it do it?
Bar is argument 1, HTTP blah blah is argument number 2, 3.
Yeah, the numbers of the arguments are documented in the documentation of the package. But the first one is the label, the third one is the second one, but the second one is somehow more escaped or something.
Yeah, I understand it. Link is a Markdown thing.
Yes.
Yeah. So there are some syntax extensions. Some of them were already supported by LunaMark. So you can write not only plain text and Markdown, but you can also mix in HTML if you want, or you can have footnotes directly in Markdown and definition list. This is what was already supported by Markdown. I added some new extensions, notably citations, the Bangkok citations, fenced code blocks so that you can easily typeset your listings, and content blocks, which is a syntax extension used in an Apple Markdown writing application, which I think is really nice. They released a sort of a draft for others to implement it. I haven't seen it implemented in any other tool, but I think they are really useful. So I'll show some examples of these. Right. So if you want to use HTML, then basically you don't get bold. The tags are just ignored. But if you have some Markdown files with HTML tags intermixed, which might easily happen because Markdown was originally meant to preprocessing to HTML, you can directly use these files and they will work as expected. Also, the nice thing is that you get comments, even with non-hybrid Markdown. So if you enable HTML in the sandbox mode, you still enable the user to put comments into their documents, even though they don't even though they can't use the person sign to produce text comments. So this is one of the nice uses of the HTML extension. Yeah, you get footnotes. Those are the basic footnotes. The basic footnotes, you have to define them, and then you place them into the text, which might not be what you want. So there are also, well, I don't think I have it in the slides, but there are also inline footnotes. You can find it in the documentation, which you just put directly in line. You don't have to create a definition and then refer to it. You just put the footnote straight into the code. You have definition lists. You get citations, and yeah, the default definition plays really well with Bibliotek at the moment. So if you use Bibliotek and you just don't override the Markdown render site macro, you just keep it as it is defined by default, then you get really nice support for text citation and parenthesized citations without touching anything. There's fenced code support, so by default the package uses the minted package, or it doesn't load it because the minted package requires shell script. So if it loaded the minted package into your document, then it could break the document. It wouldn't compile, but it checks. And if the minted package is loaded, it uses the minted package, and it passes this string, which is called the info string, to the minted package as an indication of the language of the listing. So you automatically get correctly highlighted code listings, at least in LaTeX. In context, it's a bit different. Take a look at the package. Context already has its own support for syntax highlighting, so I use that mechanism. Yeah, and these are the content blocks. So the content blocks can be used to typeset local images, which is sort of a redundant syntax for what Markdown already has. You can also use it to input any other files, which are then recognized by the extension. By default, there is support for the CSV extension. So if you input a CSV file like this, then it automatically typesets a table. It uses the CSV simple LaTeX package for that. But you can define your own mappings for the extension. So you can basically process any file included like this in a way which makes sense for the document. Yeah, and you can also use it to separate your document into individual Markdown subdocuments and then input these. Yeah. So suppose this is the file chapters01.txt. Suppose this is the file chapters/02.txt. Right. And you can also use it to load online